Hey guys, so we're going to talk about horizontal and vertical asymptotes. These are the rules for finding horizontal asymptotes. I'm not going to read through the rules because you have them. You can read through it obviously, but I will follow them and go through each one. We have an example of each down here. So the first thing you always have to do is look at the leading exponents. We have a square and a square. You also have to make sure that that is the largest one, because if this had like a plus 3x cubed at the end of it, then it would have been 2 over 3. So always make sure that you're dealing with the largest exponent of like the polynomial on top or the polynomial on bottom. So if the numerator exponent and the denominator exponent are equal, then you have to divide the coefficient attached to that x squared. So that's what we'll have to do here because they are equal. So we have squared and squared. So we will do 4 over 1, which is equal to 4. And that means that there's a horizontal asymptote, which I'm just going to write HA at y equals 4. All right, and that's how you'll know this is going over rule 1. So rule 2, we have a squared and we have obviously a 1. So our numerator exponent is greater than our denominator, and that means there is no horizontal asymptote. All right, and then down here we have, our numerator has 1 and our denominator has 3. That means that the numerator is less than the denominator. Anytime the numerator exponent is less than the denominator, then you automatically have a horizontal asymptote at y equals 0. All right, so those are your 3 cases. You're either gonna have none or 0, and then if they're equal, then you take the coefficient of the top and you put it over the coefficient of the bottom. All right, we will see that again and we'll go over it again. So down here it's saying finding vertical asymptotes and holes. This is just a quick refresher. Set the denominator equal to 0 and solve. That is to find vertical asymptotes. Always look at the denominator. Always, always, always. Okay, a hole is what you cancel out on the top and the bottom, and we will go over that. So on number 4, we have x plus 7. I'm just going to rewrite this in a simpler form over x times x minus 5. There's nothing that we can cancel out. Okay, so that means there's no hole. Okay, but let's talk about a vertical asymptote. That is only looking at the denominator, always. We're going to have 2 since we have 2 different x values. So we have one at x equals 0, and then we have one at x equals 5. Okay, let's look at this last one. Find a hole in the function. All right, we will also look and see if there's vertical asymptotes. So we have x minus 2 over, looks like we have x minus 2 times x minus 3. So since these x minus 2's would cancel out, that's where our hole is going to be. Hole at x equals 2. All right, our vertical asymptote is whatever's left in the denominator, which would be this one here, at x equals 3.